The subcommittee will come to order. I will start with my opening statement, and I want to say good morning to and thank you to today's witnesses to join the subcommittee's discussion on Aviation 2050. However, I do want to start today by acknowledging the tragedy of Sunday's crash of Ethiopian Airlines Flight 302 near Addis Ababa, Ethiopia. 8 Americans and 21 United Nations employees were among the 157 people who died in the crash. Chair DeFazio, committee staff, and I have been in contact with the National Transportation Safety Board, the Federal Aviation Administration, and Boeing about the accident, and we continue to closely monitor the investigation. I want committee members to know a couple of things. First, at the NTSB, the U.S. accredited representative and lead for the United States will assist and is assisting Ethiopian authorities in this investigation and currently has people in Ethiopia. Right now, the important thing is that relevant agencies are allowed to conduct a thorough and careful investigation. The Ethiopian Accident Investigations Bureau is the lead on this investigation with support from NTSB and others. Second, the FAA and Boeing as well have personnel in Ethiopia to assist the investigation. Third, the FAA issued a continued airworthiness notification to the international community yesterday stating pilots should continue to use Boeing's operational safety protocols as previously directed following the Lion Air crash, and American carriers must install design changes no later than April 2019. The notification does not currently call for the grounding of the 737 MAX fleet. I encourage all members to monitor the situation themselves, and I want you to know that staff is available to any member for any questions that you have surrounding the investigation and can provide updates to you as they become available. Now on with my statement for the hearing. Certainly with safety as a guiding principle for this subcommittee, I look forward to spending time exploring what is on the horizon for aviation and aerospace. For this subcommittee, Aviation and Aerospace 2050 means fostering technological innovation and improving the nation's competitiveness in the global marketplace. One of the reasons we're holding this hearing is because we want to set the record for the subcommittee for the future. Today's witnesses represent several of the emerging entrants in the national airspace, from unmanned aircraft to passenger air vehicles and supersonic flight. I'm also very pleased that current users are at the table. You will all play a vital role in the discussion on how to safely integrate these new technologies in our national airspace. As we discuss the possibilities for aviation and aerospace in the next 30 years, Congress must also ensure the U.S. remains a global safety standard in flight. Last fall, Congress passed the longest Federal Aviation Administration reauthorization in decades. The bipartisan 5-year agreement supports important aerospace jobs across the U.S., as well as better prepares and diversifies the aviation workforce. The new law raises the bar in aviation safety, increases global competitiveness of domestic aerospace manufacturers and suppliers, and safely advances drone operations in U.S. airspace. With the FAA bill as a foundation, the subcommittee can now look ahead to explore not only what is possible and on the horizon in aviation and aerospace, but what is needed to ensure the U.S. keeps innovating. One area we will continue to see tremendous growth is in unmanned aircraft systems, or UAS, or drones. UAS are flourishing in the skies at a pace we did not imagine 10 years ago. The FAA estimates that the use of small hobbyist drones will double in size to more than 3 million units by 2022, and commercial drone fleet will quadruple to approximately 450,000 units in that same time frame. There's no denying the extensive societal and commercial benefits of unmanned aircraft and their applications. Drones are used to perform critical infrastructure inspections of bridges and railroads and assist in recovery efforts following natural disasters and wildfires. With new and advanced operations aiming to take flight, several issues need to be explored. Inherent in the growth of this technology are the risks to critical assets like airports. And while we want UAS integration to be efficient, we must ensure it is safe. Just skipping ahead, on Supersonic, because of the advancements in technology, materials, and manufacturing, supersonic aircraft are on the horizon. Actually, they're back on the horizon. These flights can cut transoceanic traveling times in half, supporting passengers and international business. The U.S. does not yet have the regulatory framework to allow supersonic flight, and Congress must stay ahead of the curve, or this may lead to missed opportunities. One question you might answer in today's testimony is, how is this different than what is currently available? Foreign airlines are already investing in a U.S. supersonic aircraft company. Last year's FAA reauthorization directs the agency to exercise leadership in the creation of federal regs and standards relating to the certification and safe and efficient operation of civil supersonic aircraft. The FAA says it will initiate 2 rulemaking activities on civil supersonic aircraft. Congress must ensure these initiatives stay on track. And I look forward to hearing from today's witness about the potential benefits of supersonic transport and the challenges we have to address to ensure their safe and appropriate integration of technology. With timely input from new entrants and legacy users, U.S. Aviation will be able to tailor products and services to better meet growing passenger demands and address local challenges such as noise and greenhouse gas emissions. 2 weeks ago, the Transportation Infrastructure Committee held a hearing about pragmatic solutions to address the impacts of climate change, as well as the aviation industry's role in these efforts. The aviation industry has already committed to improving fuel efficiency by 1.5% per year, which began in 2010, achieving carbon neutral growth starting next year, and cutting net carbon dioxide emissions by 50% by 2050. I've had a chance to visit a few of these companies in my district at the forefront of innovative, energy-efficient aviation technology. For example, Zunum Aero in Bothell, Washington, is developing a hybrid electric aircraft capable of flying up to 12 people between 350 and 500 miles. The company aims to bring the aircraft to market as soon as 2022. Zunum projects its electrical propulsion prototype will cut community and cabin noise by an estimated 75% and emissions by 80%. And finally, the future of work. Emerging tech advances in U.S. aviation are only possible if Congress invests and supports the next generation of engineers, mechanics, and innovators. Unfortunately, the U.S. is not keeping pace with growing demands for talented individuals in the STEM fields. According to the Boston Consulting Group, there are 25,000 unfilled STEM jobs in Washington State alone, just in one state. Last year's FAA bill includes a comprehensive workforce development title, including my provision to create a new task force to come up with ways to encourage high school students to enroll in aviation manufacturing, maintenance, and engineering apprenticeships. The bill also creates 2 new grant programs to support pilot education and recruit aviation maintenance workers. Improving access to workforce training and preparing students to succeed is an all-around win for employers, job seekers, and the aviation and aerospace sectors. U.S. innovation is a backbone of the nation's economy and culture, and Aviation 2050 is the next chapter in our leadership in this field. Communities have already seen and experienced the significant impact of emerging technologies, and we must prepare for what is to come. The future of U.S. aviation and aerospace industries is bright, but Congress must play an important role to ensure the FAA takes steps to outline today in a timely manner so U.S. companies can continue to innovate and remain globally competitive. So again, I thank you. Thank you to today's witnesses. I look forward to the discussion, and I call on Ranking Member of the Subcommittee, Mr. Graves, for an opening statement.
Thank you, Mr. Chairman, and I want to thank all of you for being here today. And similarly, before I start opening remarks, I do want to make note that we certainly are paying close attention to the multiple aviation accidents that have occurred in recent days, and paying a special attention to the Ethiopian Air accident that occurred that killed 157, including 8 Americans. We have also been in touch with Chairman Larson, with FAA, NTSB, Boeing, and other stakeholders. But I also want to point out, as included in Mr. McBride's testimony, that air travel is the safest form of transportation in the world today. That doesn't mean we need to stop. We need to continue striving to ensure that it becomes even safer every single year as we learn lessons from different incidents and accidents. We don't know yet what caused these accidents, but we are going to be paying close attention and ensure that lessons learned from these accidents are applied to the future as well. it's important with this hearing focusing on 2050 that we actually take a look back and look at how air travel, for example, back in 1988, you had well over 700 deaths from air travel from different airlines. I think it was nearly 30 different accidents across the world. And looking back at the extraordinary reduction in deaths, while we've seen an exponential increase in the number of airline passengers that are boarding airplanes annually. Back in 1988, Chairman DeFazio just finished his first congressional hearing. Don Young, after teaching pilgrims how to grow corn, became the first, the longest-serving Republican member of Congress from Alaska. And I want to make note that just in recent weeks, Congressman Young is the longest-serving Republican member of Congress ever. 1988 was a while ago. Airlines like Pan Am, TWA, and Eastern were crossing our skies. We had just implemented the smoking ban on airplanes in that year. We've come a long way, and it's an exciting opportunity to think about what 31 years from now will truly look like. We have a chance to totally reinvent the airspace, not only incorporating new entrants like drones, flying cars, commercial space travel, but also the chance to pave the way for the next big idea that changes the way that Americans travel. We in Congress usually are responding or being reactive. We're dealing with how things are, not the way that we want them to be. And having worked for many years in areas like water infrastructure and transportation infrastructure, aviation is exciting. And that, as witnessed by the folks on the panel today, this industry is driven by the private sector. And obviously, Mr. McBride, as you noted in your testimony, with much R&D and support from NASA and our federal partners. But it's driven by the private sector. And as Ms. Cooper notes in her testimony, with Part 107 implementation, it somewhat allowed us to lead the world in different types of innovation and technology, but we also, if we do not continue to be pushing, to be planning for the future, to listen to folks like you on how we can lay the groundwork to continue innovation, we risk losing that competitive edge, we risk losing innovation, we risk losing the opportunity to truly lead the world in infrastructure. My home state of Louisiana, Baton Rouge and New Orleans are two of the most traffic congested areas in the nation. And looking at technologies like we're going to hear from Mr. Allison on Uber Elevate and how that type of technology can play into addressing our traffic transportation infrastructure planning in the future is truly exciting. And Captain DePete hearing about how we're going to address, as is noted in testimony, the nearly 790,000 pilots that are going to be needed in the future, and addressing that demand for aviation travel is something that we're going to need to be spending a lot of time on. Last note, when you look back at the onset of aviation travel, we were using prop planes, and when we transitioned into jets, we were able to reduce to nearly 1/3 the amount of time it took to travel. With technology we're going to hear from Mr. Foredo today, we can potentially cut that again by 1/2. I mean, this is really exciting times. It's not like transportation infrastructure or water infrastructure, roads and water. This is an opportunity for us to be thinking forward, leaning forward, and truly planning for the future. Looking forward to hearing your testimony and learning how we can lay the groundwork to ensure that we're a partner, not an obstacle.
Thank you, Representative Graves. Now I want to welcome our witnesses. Mr. David McBride, Director, Armstrong Flight Research Center of NASA. Ms. Diana Cooper, Senior Vice President, Policy and Strategy at Precision Hawk Incorporated. Mr. Eli Dorado, Head of Global Policy and Communications at Boom. Mr. Eric Allison, Head of Elevate Uber Technologies Incorporated. And Captain Joe DePete, President of the Airline Pilots Association International. Thank you all for being here today, and we all look forward to your testimony. I ask unanimous consent that our witnesses' full statements be included in the record. Without objection, so ordered. Since your written testimony has been made part of the record, the subcommittee requests that you limit your oral testimony to 5 minutes. And with that, we will start with Mr. David McBride of NASA. You're recognized for 5 minutes.
Thank you for that opening comment. Chairman DeFazio, Ranking Member Sam Graves, Chairman Larson, Ranking Member Garrett Graves, and members of the committee, thank you for this opportunity to testify on the vision of the national airspace for 2050 and NASA's role in shaping the future developments of the airspace. Imagine with me for just a moment a vision of our nation's transportation system could look like in 2050. Imagine you're a business person in Arlington, Virginia. You leave home early. You hop a rideshare to the airport, a car, or an air taxi. A supersonic passenger jet takes you from D.C. to Seattle in about 2 hours. Upon arrival, you fly from the airport to your meeting in an air taxi. Your business partners order a fresh lunch delivered by a drone, and perhaps you're studying wildfire damage with images sent in real time from first responders using unmanned vehicles flying over remote areas. By early afternoon, you head back to the airport. That evening, you're at home in time for dinner with your family. Enabled by aviation, this is a world with urban air taxis, drones delivering packages and collecting data, new opportunities for mobility benefiting consumers and passengers, expanding tourism and business travel, and U.S. companies delivering these products and developing aviation services of the future, creating high-quality manufacturing and service jobs. Aviation generates $1.6 trillion in total U.S. economic activity per year and contributes about 5% to U.S. GDP. Aviation in the U.S. supports 10.6 million direct and indirect jobs and generates the largest positive trade balance of any manufacturing sector, over $84 billion a year. Innovation and growing economies will double global passenger air travel in the next 20 years. Industry predicts the demand for over 42,000 new transport aircraft in the next 20 years and a market worth over $6 trillion plus another $3 trillion in aftermarket services. This growth in aviation means jobs. Industry estimates that aviation will need almost 800,000 new pilots by 2037, and there will be similar growth in jobs for manufacturing, technicians, and aviation services. Global competition is fierce in this sector as companies and countries seek to capture a larger share of this growing market and high-wage jobs. NASA Aeronautics is uniquely positioned to be the catalyst for this exciting future and to ensure U.S. maintains a strong leadership role. NASA research is in the DNA of every aircraft flying today. The United States has the safe global air transportation system we have today because of NASA research. We also work closely with FAA leaders and technical experts to ensure our research meets their long-term goals and can inform their investment decisions. Our research transition teams serve as the bridge between NASA's long-term game-changing technology R&D and FAA's near-term R&D to support implementation and certification. NASA is investing in the discovery of new concepts and technologies in key areas. Over the past decade, NASA fundamental research has demonstrated the possibility of supersonic flight with greatly reduced supersonic booms. NASA is now building a quiet supersonic experimental aircraft, the X-59 Quest, to provide proof. While subsonic aircraft will still carry the majority of passengers in 2050, those aircraft will be different from today. Large leaps in aircraft efficiency, coupled with reductions in noise and harmful emissions, are critical to the sustainability of aviation. Future aircraft will look different, will be made from different materials, will be powered differently, and will even be designed and manufactured differently. NASA is leading research into new components, technologies, and powertrain architectures for electric or hybrid electric systems that can bring about revolutionary improvements in small and large transport aircraft. Ground tests this year and flight tests next year will provide valuable insights into the challenges and opportunities of electric aircraft and serve as the building blocks for industry to create future safe and certifiable aircraft designs. Autonomy and increased automation will also bring new opportunities to do the things we do already even better. In 2050, UAS or unmanned aerial systems will be fully integrated into the airspace. NASA research will enable the safe integration with the ability to detect and avoid other aircraft, assured command and control communications between the UAS and the operator on the ground, human systems integration capability, and approaches to determining airworthiness requirements. The potential benefits of UAS grow exponentially if they can operate safely in great numbers. NASA has developed a concept called UAS Traffic Management, or UTM, to overcome this challenge. UTM develops software tools used by air traffic controllers and airlines to fly more efficiently in increasingly congested airspace and investigate applications of UTM concepts to the entire airspace. NASA is preparing a series of grand challenges that will provide a means to assess maturity of key systems for urban air mobility, and although initial UAM operators are likely to use piloted vehicles, autonomy and increased automation will make it truly accessible to all citizens. NASA is developing software tools used by air traffic controllers and airlines to fly more efficiently in increasingly congested airspace. And NASA will hand off research results of our cutting-edge research to U.S. industry for further development and commercialization. Thank you for the opportunity to testify today, and I look forward to your questions.
Thank you, Mr. McBride. And now turn to Ms. Diana Cooper, who's a Senior VP, Policy and Strategy at Precision Hawk Incorporated.
Chairman
Recognized for
Larson,
5 minutes.
Chairman Larson, Ranking Member Graves, and Ranking Member Graves, members of the subcommittee, thank you for calling this hearing and for the invitation to testify on behalf of Precision Hawk. Precision Hawk is emblematic of the current and future state of the growing commercial UAS industry. I appreciate the opportunity to appear today on this distinguished panel representing the future of American aviation. I would like to begin by thanking Congress for passing the FAA Reauthorization Act of 2018 and for providing the necessary funding to the FAA to integrate UAS into the national airspace. These measures establish critical building blocks to help the U.S. realize the economic, consumer, environmental, and humanitarian benefits of drones. Precision Hawk employs 187 people with offices in North Carolina, Virginia, Illinois, and California. We provide advanced drone software and services across agriculture, energy, construction, insurance, and government sectors. Our algorithms detect plant disease, forecast crop yield, and assess storm damage. And our Lattice platform provides safety information that supports geofencing technology in roughly 80% of civilian drones in the U.S. We pride ourselves in conducting operations that serve the public interest. With Booz Allen Hamilton and Concourse, we use drones to support an environmental impact study for the Department of Veterans Affairs West LA campus. The data collected was used to build a digital twin to support master planning and redevelopment efforts. Last fall, Precision Hawk deployed drone teams to aid in the response efforts after Hurricanes Florence and Michael. Working with the North Carolina DOT, we used drones to deliver imagery and video of impacted bridges, dams, and roads. This enabled real-time decision-making about road closures and evacuation routes. The data collected was also used to support the expansion of a federal disaster declaration to additional counties in the state. Precision Hawk also worked with utilities to locate downed power lines and flooded substations to help restore power faster. Additionally, we use drones to assess storm damage to help process claims to get people back into their homes more quickly. UAS are having a positive impact on the American workforce. The low cost and ease of use of consumer drones has made the practice of aviation accessible for the first time in history. For some pilots, flying begins as a hobby and later turns into a career. Drones enable worker safety in the mining, energy, and insurance industries. Climbing roofs or utility poles can be hazardous tasks. By outfitting workers with UAS, we are helping them perform their jobs more safely. Drones are also opening up employment opportunities for people who face mobility challenges. In rural Missouri, Andrew Custer suffered a tragic injury that left him partially paralyzed and confined to a wheelchair. Andrew started his own drone business inspecting power lines and rooftops, surveying farms and construction sites. Drones provide him with the ability to be gainfully employed, doing work that would otherwise be impossible. The future use cases of drones are only limited by our imagination. By 2050, we will achieve full integration of the national airspace at low and high altitudes, including all of the vehicles represented today on this panel, and vehicles not yet imagined. We will break the paradigm of a single drone completing a single mission. Drones will also trigger automated actions including inspection, repair, and insurance claims processing. Drones will prevent disease outbreaks from happening and will provide early warning signals when plants and animals are about to become endangered. In 2016, the U.S. took the global lead in establishing regulations that govern basic commercial operations. We must act today to maintain our leadership by setting the standard for remote identification. Remote ID will enhance safety, security, and privacy. In 2017, the FAA convened an advisory committee to make recommendations on remote ID, but the wait for a proposed regulation continues. The government has made it clear that remote ID must be implemented before any additional rulemaking for advanced operations. We respectfully ask Congress to ensure that the FAA publishes proposed remote ID regulations without any further delay. It is critical that the federal government open the door to the promise that UAS are certain to yield. Thank you again for the opportunity to appear today. I look forward to your questions.
Thank you for your testimony, and I want to turn now to Mr. Eli Dorado, Head of Global Policy and Communication of BOOM. Thank you.
Thank you. Thank you, Mr. Chairman, and thank you to you and to the members of the Aviation Subcommittee for hosting this hearing and for the opportunity to share how today's advanced civil aviation technology is creating a more accessible world through a supersonic renaissance. At BOOM, our mission is to eliminate the barriers to experiencing the planet: time, money, and hassle, starting with the long hours spent on long-haul flights. Why do these barriers to experiencing the planet matter? Because when those barriers are in place, people simply don't travel as often. For context, think about the world before jet airplanes. In the late 1930s, flying on Pan Am from LaGuardia to Lisbon took more than 24 hours. Only 20 years later, at the dawn of the jet age, the same flight took only 7 hours. Travel skyrocketed. You might think that since jets were 3 times faster than the airplanes that they replaced, people would spend about a third of the time on airplanes. In fact, with the burden of a 24-hour flight removed, people spent much more time on airplanes because they traveled much more often. Speed, therefore, isn't about saving time. It's about new possibilities for travel and human connection. While the world got a glimpse of another travel speed-up in the 1970s with Concorde, it wasn't an economically sustainable advance. Although the program was a marvelous technical success, only 14 Concordes saw service, and even though the airlines bought them for £1 British, they weren't profitable to operate, sometimes flying with 75% of the seats empty. The world has now gone 6 decades without a lasting increase in the speed of long-distance travel. Crossing the Atlantic takes as long today as it did in 1959. We believe the world is long overdue for a speed-up, and in 2019, we have all of the technology needed to build an economically viable, environmentally responsible supersonic airliner. Applying technologies developed for the subsonic market to a supersonic design, BOOM will deliver a Mach 2.2 airliner called Overture by the mid-2020s. Overture is designed to profitably replace today's transoceanic business class service. With Overture, as with the first jets, faster speeds are about new possibilities rather than just less time on airplanes. Today, a flight from New York to London takes around 7 hours and is often flown as a red-eye. On Overture, because the flight takes only 3 hours and 15 minutes, a New Yorker can take a 6 a.m. flight out of JFK, arrive at Heathrow in the early afternoon, travel downtown, meet with clients, and take them to the pub before catching a 9 p.m. flight home, arriving back in New York in time to tuck her kids into bed at night. Today, a flight from San Francisco to Tokyo takes around 11 hours, and to attend a Monday morning meeting in Tokyo, you have to leave the US on Saturday. With Overture, because the flight takes only 5.5 hours, you can leave a full day later, arrive on Monday morning, have a full day of meetings, fly home, and be back 24 hours after you left. The full trip shrinks from 3 days to 1 day. Importantly, this isn't a science project. No fundamental research is necessary. All the technology to build Overture exists. And later this year, we are rolling out our supersonic demonstrator aircraft called XB-1, which is now under construction in our hangar in Colorado. When XB-1 flies its design cruise speed of Mach 2.2, it will earn the distinction of history's fastest civil aircraft. XB-1 and Overture are only the first steps in achieving our mission. To truly make our planet accessible for all, we need to further increase speed, reduce costs, increase passenger comfort, relaxation, and productivity. We expect to make progress on all of these fronts with each airliner model we design. Eventually, we see a world in which no trip anywhere on the planet takes more than a few hours, fares are lower than today's economy prices, and the experience of travel is serene and productive. Travelers should look forward to the few hours they'll spend in an airline seat. I look forward to discussing the future of flight with this subcommittee and to working with you all to build a more accessible world. Thank you.
Thank you, Mr. Dorado. I now want to turn to Mr. Eric Allison, head of Elevate Uber Technologies. You're recognized for 5 minutes.
Thank you. Mr. Chairman, Ranking Member Graves, and members of the subcommittee, it is a privilege to be here today before you to discuss the role that Uber will play in delivering aerial ride-sharing services in the years ahead. My name is Eric Allison, and I'm excited to lead Uber's Elevate initiative. Last year, Uber changed its mission statement to reflect its ambition and purpose. We ignite opportunity by setting the world in motion. Elevate is an embodiment of this mission. We envision a future where anyone can open the Uber app, push a button, and get a flight, setting people in motion like never before as we radically improve urban mobility. To enable this future, we are developing our Uber Air product, a real-time, on-demand network of short-range intra-city aircraft that will deliver time savings on a massive scale. So why is Uber doing this? We know that every year, millions of hours are wasted in traffic worldwide. In fact, the Los Angeles Times reports that LA is the most congested city in the world, where residents lose over 100 hours each year to traffic. This problem will only get worse as populations grow and ground infrastructure is unable to keep up. Today, around half of the world's population resides in urban areas, and the United Nations predicts an additional 2.5 billion city residents by 2050, overwhelming already strained infrastructure. Uber believes that solving these problems is core to our business. We can't ignite opportunity when the world is stuck in traffic. Since publishing our Elevate white paper in 2016, we have worked diligently to answer the following questions. Why don't people fly in cities today? And what are the barriers to urban aviation becoming a large-scale mode of transportation? We have identified an approach to systematically tackle each of these challenges, and our analysis projects that aerial ride-sharing is not only feasible, but can be offered at rates affordable enough to make everyday flight accessible around the world. To achieve this vision, over the next 3 years, we aim to conduct meaningful demonstrations of all-electric vertical takeoff and landing aircraft in Texas and California, and commence certified commercial operations in 2023. In order to deliver on this ambitious timeline, we recognized early on that we can't do this alone. Broad-based partnerships with government and industry are critical to achieving our vision. We are partnering with companies such as Boeing, Bell, Embraer, Pipistrel, and Karam Aircraft. These leading manufacturers and innovative new entrants are perfectly positioned to pave the way for quiet, safe, reliable, and affordable Uber Air taxis. The Federal Aviation Administration is another incredibly important partner in this journey to make urban aviation a reality. We firmly believe that certification of air taxi vehicles through the recently revised Part 23, which was supported by this subcommittee in the form of the Small Aircraft Revitalization Act, is the best path forward. We encourage the FAA to commit to using Part 23 to safely and expediently certify these new aircraft, firmly establishing United States global leadership in this innovative new category. In addition to our partnership with the FAA, we're pleased to have signed 2 Space Act agreements with NASA, one for the development of UAS traffic management concepts and technologies, and another to explore urban air mobility. UTM is paving the way for Uber and other companies to drive innovation and develop airspace services that manage vehicles safely and efficiently without putting an undue burden on existing air traffic operations or air traffic controllers. At Uber, we are investing in aerial ride-sharing because we believe in the future of aviation and changing the way the world moves. By 2050, we will no longer be discussing our work to develop battery technology, our transition from piloted aircraft to autonomous, or our ability to fully integrate into the urban airspace. Rather, in 2050, we intend to be safely and autonomously operating millions of daily flights, fully integrated into the national airspace system, and with 0 carbon emissions. Working with world-class leaders in the aerospace industry and our government partners, we believe we can bring about lasting positive change for the world through 2050 and beyond. In addition to our daily work to advance urban aviation, this June we will be holding our 3rd annual Elevate Summit right here in Washington, D.C., presenting never-before-seen developments and showcasing exactly how close we are to making aerial ride-sharing a reality. We want to do this in concert with policymakers like yourselves as we move closer to bringing Uber Air to major cities in the United States. We hope you'll join us for what will undoubtedly be an exciting 2 days. To give you a sense of how users will live this future transportation experience, I would like to close with a short video illustrating Uber Air. I hope you enjoy this fast forwarding to the future, and I look forward to answering your questions about our vision and approach. Thank you.
Thank you. We're going to run that video right now.
The planes work better than the sound.
Thank you. I think it also proved how quiet it can be in the future.
It's very nice music.
Thank you. And then I want to recognize Captain Joe DePete, who's the president of ALPA, the Airline Pilots Association International. Recognize you for 5 minutes.
Thank you, Chairman Larson, Ranking Member Graves, and the subcommittee for the opportunity to be here today. Before I begin, please let me take a moment to recognize the Ethiopian Airlines and Atlas Air accidents recently. Our thoughts are with all those affected, and ALPA is committed to helping the industry take every possible action to prevent such tragedies in the future. Now, regarding today's hearing, we at ALPA understand the economic and societal value of the safe integration of new types of operations into the airspace. As a 40-year pilot, I can also tell you that airline pilots are very excited about flying in the future. Wilbur and Orville Wright were original innovators in aviation and the first of many innovators in the United States airline industry. With every year, innovation has brought greater safety to our skies, and I'm proud to say I believe that ALPA's work in safety, security, and pilot assistance, and our support for technological innovation are among the reasons why flying is the safest mode of transportation today. As head of the world's largest non-governmental aviation safety organization, I can tell you that maintaining one level of safety throughout the national airspace is essential to fostering the innovation of tomorrow. The national airspace is a shared resource for all Americans, whether it's passenger and cargo airliners, UAS, urban mobility, super and hypersonic flight, or commercial space. The same high standards must apply to all who use it, or all are at risk. The United States owes it to our future to benefit from the lessons of the airline industry's past. One lesson we learned is that innovation is key to solving the greatest challenges and to keeping flying safe. From developing centerline approach lights to using technology to reduce in-flight collisions and helping shift the industry to a proactive safety culture to prevent accidents, ALPA is all about innovation. In fact, one of our industry's most valuable safety tools, voluntary, non-punitive safety reporting programs, sets the stage for this innovation. These safety reporting programs allow pilots and other aviation professionals on the front lines of daily operations to report safety hazards before they cause accidents. Safety risk issues are then prioritized by the Commercial Air Safety Team, Aviation Safety Team, or CAST, and used to improve policies, procedures, equipment, and training. Made up of representatives from the government, labor, airlines, manufacturers, the CAST is a synergy on a massive scale, and it has saved lives. Together, CAST representatives focused on reducing U.S. commercial aviation fatality risk. The team exceeded its initial 80% target, and I'm proud to say it's reduced the current risk rate now today by 91%, a remarkable achievement by any measure. The CAST model is one of the aviation industry's best practices, and it shows how U.S. innovation and collaboration have created an extremely safe air transportation system. Another aviation best practice is our recognition that the most important safety asset on any commercial passenger or cargo airliner are at least 2 fully qualified, highly trained, and well-rested pilots in the cockpit. This lesson is critical to consider as many new types of flight operations are envisioned to be autonomous, meaning no pilot is involved in the flight. When it comes to integrating new types of operations into the national airspace, we have the opportunity today to do it right the first time. Expanded markets and technical advancement are creating exciting developments in aviation. Accommodating that growth presents regulatory and shared public resource challenges. We need Congress to lead our industry in planning for that now. We must be bold. The FAA and the TSA must be given the resources to innovate through programs like NextGen. And a government shutdown can never, again, be allowed to stop the FAA's life-saving work. ALPA offers decades of experience combined with our unique perspective from the cockpit. We're committed to collaborating with all who share the national airspace to ensure safety. So as we consider aviation in 2050, we have an opportunity to innovate not only on how we use our national airspace, but how we keep it safe. Together, we can protect what's most important to us all, our passengers, participants, crew, and cargo. Thank you very much.
Thank you, Captain, very much for your testimony and your service to the flying public.
Thank you.
I want to now recognize members for member questions. Each member will be recognized for 5 minutes. I will start with myself, and I'll start with Mr. McBride. I do want to correct your testimony. Your business traveler in your example would have flown from Arlington, Virginia to Seattle, and she would have stayed and had her family then fly out to meet her, and they would have stayed and not flown back here. So if you fix that, I think we'll be all right. No, in your written testimony, you state that UAS will be fully integrated in the airspace in 2050. In your view and NASA's view, looking at your research, what's the first and most important step to make that happen?
Well, the things we're working on with the UAS and the NASA activity, NASA's been involved with integration of unmanned aircraft for the past 20 years. The latest effort is UAS and the NASA. The key technologies that we're working on is detect and avoid to assure the piloting community and the FAA that UAS can detect and avoid autonomously or with equal acuity as a human pilot other aircraft in flight.
So in airplanes now, there's, you call it detect and warn, I suppose, detect and warn the pilot. How advanced are we in the detect and avoid technology deployment?
The detect and avoid technologies come along well. Good sensors on board with both cooperating and non-cooperating aircraft. The cooperating aircraft would be aircraft with transponders or broadcasting their location, but also with non-cooperating flying vehicles from balloons to simply GA airplanes that may not have a transponder on board. So making good progress. We did have a good demonstration this past summer of the no chase COA with our MQ-9 Econo aircraft, and that activity was recognized with an Aviation Week Laureate award this past week.
Okay. Ms. Cooper, you're on the Remote ID or Remote Identification Aviation Rulemaking Committee in 2017 for the FAA. Why do you think it's taken so long for the FAA to get that rulemaking in place?
Thank you for your question, Chairman Larson. I can't speak for the FAA, so I'm also wondering why it's taken so long since industry as a whole provided great recommendations on how to roll out remote identification. I understand there are security agencies that also need to take a look and weigh in on the rule. I'm hoping that this committee can help us, unlock the rulemaking for remote ID so we can move forward.
So explain to the members what moving forward means. Why is remote ID a remote ID rule needed?
Thank you for your question. A couple of years ago, the FAA was ready to put out a proposed rule for operations over people, and it was clawed back due to security agency concerns. The concept was, today we understand if we see a drone flying over a crowd, we understand it's illegal, so we know that that's a threat we need to take action against. But if everyone's generally allowed to fly under a rule over people on a regular basis, it'll be very difficult to discern a friendly drone, say operated by a news agency versus a rogue drone looking to do some harm. And so the idea is, let's implement remote identification requirement across the board with UAS operators so that law enforcement can easily identify through the electronic license plate who's operating in the airspace and to understand if they're a threat or not.
All right, thank you. I think we ought to look further into that. Mr. Dorado, what's different about Overture compared to SST? What's changed in 30 years in the technology to make this product more of a reality? Get your microphone, please.
Thank you, Mr. Chairman. I think there's basically been three major advances that make now the right time. So one is computational methods for design. So hard to believe, but Concorde was designed on paper with slide rules, and it's a remarkable achievement. We have discovered. We continue to be impressed with what the engineers of that era were able to accomplish in designing a Mach 2.0 airliner with Concorde. With computational methods, we can do sort of a virtual wind tunnel test daily. Run several in parallel, whereas these wind tunnel tests took 6 months of time and several $1 million for Concorde to do. So we can iterate more quickly and improve the aerodynamics. Another huge advance is improvements in materials. So Concorde was designed out of aluminum. Aluminum is very expensive to tool in a way that that has the flowing shapes that our aerodynamicists require, and it also does not hold. The thermal stability is not as high. So Concorde actually would grow over a foot in length over the course of each flight, and then shrink as it cooled off. And then the third major advance is in propulsion technology. So jet engines get better at a rate of about 0.5% to 1% every year, which over 50 years is a non-trivial improvement in fuel efficiency and so on. So whereas Concorde flew with 4 turbojet engines with afterburners, we're down to three engines with modern turbofans and no afterburners. So it's much more fuel efficient, it's quieter, and it pollutes a lot less. So it's just huge advances applying the subsonic improvements of the last 50 years to a supersonic design, and we look forward to innovating in the future with supersonic specific technologies, but none of those are needed for the first model.
All right, thank you. I have further questions, but in fairness to the committee members, I'll move to Mr. Graves of Louisiana for 5 minutes of questions.
Thank you. I want to thank you all again for being here and for your testimony. And I want to reiterate, it's very exciting to be able to think forward and be able to plan for what we need to be doing now to prevent government from becoming an obstacle or impediment, but rather a partner with you in your innovation efforts. I want to ask each of you just to simply answer the question, what do you see as being either the biggest opportunity or the biggest impediment for government to step in and help to facilitate innovation, to help facilitate some of the technologies that particularly the three of you in the middle are working on right now? I'm curious your response.
So I think the biggest opportunity we have covers all three aspects that we've heard here today. Advancements in supersonic aircraft that'll open up the high end of the market, improvements in subsonic aircraft, which will greatly improve the efficiency of today's aircraft, although the picture you presented, Mr. Graves, from 1988 shows a great improvement from then to today. There is still room for aircraft efficiency, maybe on the order of 50% improvement yet by this 2050 goal. And then integration of unmanned aircraft. That is a market that 5 or 10 years ago we didn't see expanding and exploding as it is now with urban air mobility and the ability to transport packages and people and sensors. So there's all three aspects are ripe for commercialization and further market improvement.
Thank you for your question. Unmanned traffic management is the biggest opportunity for our industry and for many of the vehicles represented at this table to be able to share the same airspace safely. UTM is a concept born out of NASA's work at Ames, and many industry players, including our company, have already developed commercial aspects of UTM technology. Congress also directed the FAA and the Reauthorization Act to figure out a process for rolling out early phases of UTM in low-risk areas. So thank you very much for your support with that provision, and we look forward to the FAA rolling that out.
For Supersonics, I think the two opportunities are for FAA to continue the two rulemakings that they have underway that were in the FAA reauthorization bill. So one is to clarify to create noise standards for takeoff and landing. No airplane can be certified without a noise standard, and none exists for supersonic airplanes. So FAA is working to put a standard in place. And the other is to clarify the testing rules for supersonic aircraft over the United States. It's illegal to operate supersonically without a special authorization. And the way that you get that, or how that's going to work, affects our ability to test aircraft and to do certification testing and production flight testing.
And of course, NASA is working on technology right now that would believe to help, and I guess building an aircraft to help demonstrate a technology where you're reducing the sound. Mr. Allison?
Yeah, thank you for the question. I think in general, we all work in this very highly regulated industry, and so it's going to remain that way, and it needs to remain that way to ensure the safety of operations that we all care deeply about every time we fly in an airliner. But I think that what we need from regulators is clarity of pathway, which I think is essentially what we've all been saying here, that we need to have clarity on the rules that manufacturers and operators in these new fields and in these new types of technologies that we're working on, so that they can innovate. Because setting the fences, clearly defining the fences and allowing the innovators to innovate within those boundaries is the best way to unlock the speed of innovation that we all want to see. And in urban air mobility in particular, I think what we see the FAA doing a good job at is starting to define this pathway for certification of the vehicles, and then how does the operations come in as well, because what we're talking about is a different type of vehicle and different type of operations from the way that the rules have kind of grown to be based on the technology that existed when they were written. And so we have to see that continued progression toward clarity of the rules, that the manufacturers and the operators can innovate within those.
Thank you.
Thank you, Ranking Member Graves. I think the biggest opportunity is the success that led us to the safest period of time in aviation history was through collaboration and leadership. I have never, pardon me while I fall back to my Marine Corps days, but I haven't seen a situation that either couldn't be solved or better managed through good leadership. And we've got that. And in fact, I think I owe everybody in this room a debt of gratitude, because this latest FAA reauthorization was just a fantastic achievement. And closing the gap with the hobbyists was a fantastic move. You made it safer for everyone that flies. Having said that, I think some of the biggest challenges would be a steady stream of reliable income for the government to stay open. Closing down government, to have a 5-year FAA Reauthorization Act, and to have so many good plans and good ideas and go through the starting and stopping, I just don't see how we can achieve our goals efficiently in that manner. So,
thank you.
Thank you. Recognize Representative Lipinski of Illinois for 5 minutes.
Thank you, Mr. Chairman. Thank all the witnesses for testifying today. It's fascinating to think about what the possibilities are that are available, and more than I think most people know is already possible. I wanted to ask Mr. McBride a little bit more about the, if you could expand on types of testing that NASA and FAA are doing with regard to UTM, and how this is going to change as we go forward. There's, is it, I assume it's simulation-based testing right now, and what about moving to real-world testing as this progresses, so that we actually know that it's going to all work when it gets going?
It is simulation-based testing, but also integrating actual UAS or UAV flight test and surrogates and flight test. We're doing a virtual airspace test for a weekend, fly over restricted airspace at Edwards Air Force Base, but overlay that data real-time with real traffic in busy FAA traffic sectors. So we're flying UAVs in restricted airspace with no traffic around it, but the FAA controllers are seeing that flight overlaid on top of actual busy traffic. We're taking that also to flying our UAVs in busy traffic corridors. Again, I mentioned this past summer we did the UAS, the NAS, No Chase COA, where we flew through the Central Valley of California in and amongst air traffic, and air traffic controllers saw and spoke to the aircraft as if it were a manned aircraft. So we're doing both virtual and simulated and overlaying both of those together to mimic the real airspace.
And how do you envision the certification working for the new unmanned systems?
NASA's working together with the FAA to develop minimum operating procedures and standards to develop those basic rules. The original starting point for FAA is with a manned pilot with detect and avoid as a human eye could detect and avoid and maneuver to avoid other aircraft or terrain. And so NASA's developing, along with FAA and our partners at DHS and DoD, standards that'll enable a baseline for that minimum operation standards that an industry could then manufacture or design to.
And I want to ask Mr. Allison, right now we have a robust network of businesses that support aircraft operations, companies that provide ground handling, fueling, maintenance, passenger accommodations. How do you see all this changing?
Thank you for the question. We've taken a very partnership-forward approach in everything we've done with Elevate, and so we actually look forward to partnering with many of the companies that do various different types of operations right now in the current types of typical commercial operations as we develop the Elevate network of air taxis going forward. So we think there's great opportunities to both expand businesses and create new businesses around these types of electric aircraft, which will have some new and unique types of maintenance and operational considerations, but an opportunity to expand existing offerings to partner with us to bring this to the world.
And where do you envision this, the maintenance and all the other ground operations happening at airports as they exist now, or envision something else?
So we envision a network of relatively short-range all-electric aircraft. So our mission specification that we've derived from very extensive simulations that we do of existing traffic patterns in cities suggests that an aircraft with a range of something like 60 miles, max range of 60 miles plus a reserve, after that, will then operate within the network kind of in an average trip length of about 25 to 30 miles. And so they're relatively short-range things. And so what we have to do is have essentially maintenance depots and hubs on the outskirts of the areas where we'll be operating, where there will be the kind of the ongoing types of maintenance that we hope is actually dramatically less than typical aircraft today, because with all-electric aircraft, just as with all-electric cars, the maintenance requirements are much, much lower because the mechanicals are just vastly simplified in these vehicles.
All right. Thank you very much. Yield back.
Thank you, Mr. Lipinski. Before we move on, I just want to remind people we're calling folks in the order of seniority at which you were here at the gavel. Then if you're here after the gavel, then you're put on the list in the order that you were here. So it may seem a little random, but there's a method to the calling of folks. Before calling on Representative Spano from Florida, just a heads up that Mr. Allred from Texas will be the next Democrat called upon. For 5 minutes, Mr. Spano from Florida.
Thank you, Mr. Chairman, and thank you for putting together this meeting today. Very, very informative, and thank you all for your input today. I'm very grateful for it. One of the things that we talk about a lot, and it's true, but we discuss it a lot, is the importance of having people who are able and willing and knowledgeable to serve in the economy as you're moving forward, right? And so one of the big things, if we're expecting the aviation industry to boom like we hope it will and expect it will, we're obviously going to have people, young people now that are getting educated, that are excited, that are motivated to get into the industry. So I would love to hear what your various opinions are. If you can answer just briefly for me, each one of you, what is it that we can do to encourage this next generation of people that are going to be working in the aerospace industry?
Well, one thing we do is provide interesting and exciting technology for young people to work on. I started my career with NASA in 1982 as an intern, as a cooperative education student, and that helped me get through college and become an engineer. I think what we can do is continue that path and keep providing exciting work in the work we've heard described here at the table today. Is certainly merits and would bring on that next generation of students.
Mm-hmm.
Thank you for your question. Drones provide a perfect entry point for the youth to get engaged in aviation. The low cost and ease of use of the technology, it's being spread through STEM programs across high schools across the country, and it's bringing new life into the aviation space. So, I think one thing we can do is keep that in mind, that, often the youth are engaging from a hobbyist perspective, and then they'll grow to be aviators as a career. We need to keep that in mind when we're looking at rules that regulate the very young, novel users of this technology.
I want to echo what Mr. McBride said, that it's I think really about inspiring people by the amazing things that we can do as an aerospace industry. I think right now when young people look into what career they want to do, they don't want to spend their whole career as an aerospace engineer designing a slight tweak to a winglet on a subsonic airliner. That does not spark joy. And I think if we can show that aerospace really can change lives and can develop rapidly and can be an exciting field to work in, that's how you get people into those fields.
I want to agree with everything I just said. I thank you for the question. I think it's really, really important to think about this. How do we inspire the next generation of both leaders and engineers that will be creating this? I remember back when I was a young child and the first space shuttle was launched, and remember the National Geographic magazine that had the picture of that on the cover, and I think that probably was pretty formative in terms of the way I thought about things that I wanted to do. And I think that's why we've placed a pretty heavy emphasis on telling the story of what we're doing pretty early on. And being pretty public about that, and really trying to lean into that, because we think it's really, really important to inspire the community, the ecosystem of companies that have to exist, but also of dreamers that have to exist to then be participating in this, to bring the next generation to bear to create these amazing technologies. Thank you.
Thanks for the question. This is a particular area where I feel like ALPA really, truly shines. We've been involved in that effort for a really, really long time. In fact, our top 3 strategic plan priorities, the Airline Pilots Association, is safety and security, pilot representation, and then the future of the profession. Last year alone, we visited over 15,000 secondary and primary education universities around the country. And in fact, a week from now, I'll be at Embry-Riddle Aeronautics University to do the same, to inspire the youth. We're also heavily invested in promoting STEM programs, and so every step of the way, we are trying to build a future and a pipeline for new pilots to come into the programs. But importantly, all those other factors I talked about, the safety and the representation end, to maintain a viable profession that people would want to come. I mean, love of flying is great. It is what truly inspires us all. But you have to have a viable career along with it all. So it's a package.
Yeah. Thank you.
Thank you, Mr.
Chairman, I yield back.
Thank you. Mr. Dorado, 5 points for the first pop culture reference for the day, -5 for your choice. I recognize Mr. Allred for 5 minutes.
Thank you, Mr. Chairman. And thank you to all the witnesses for being here today. Mr. Allison, I'll largely be directing my questions to you because I represent Dallas and the northern suburbs of Dallas, and we are one of the fastest growing cities in the country, and we are grappling with the traffic congestion problems that come along with that growth, and our growth is not going anywhere, right? And we also have, I think, a rich history of aviation. We have a number of great aviation companies and transit hubs in our area, and so I'm extremely excited about your pilot project in Dallas. But while the idea of hopping on an air taxi and being able to leave all of that congestion behind sounds great, we obviously have to address some of the hurdles and safety issues that might come up as part of that. And I want to talk to you a little bit about that. Uber Elevate has plans to begin flight tests in Dallas next year, with commercial operations beginning in 2023. In addition to pilots, what types of jobs will these commercial operations bring to my area?
Great, thank you for the question. Yes, we intend to, working in conjunction with our partners who are actually building the vehicles, start demonstration flights to be able to demonstrate to the communities that we're working in, like the Dallas Metroplex, the value, the value proposition essentially of the quietness and kind of helping people to understand where the technology is going, and that's really why we're leaning into doing this as early as we can, and we won't do it any earlier than it makes sense to do it safely. And we think that by moving expeditiously through the certification process, it's possible to get to certified commercial operations by 2023, but obviously that depends on the regulators and the companies that are working with the regulators to kind of move through that process in the right way. We can't start operating things until they're certified, and we won't start operating them until we're sure that they are safe and meet the standards that we think are necessary to operate this type of a network. So there'll be lots of different types of jobs that will be created in this type of a service. Everything from pilots, because we believe that these vehicles will be piloted in the initial iteration of this type of a service. We think in the long arc, when we're thinking 2050, we think that there is this long-term trend toward autonomous operations, especially for smaller vehicles. It makes a lot of sense. But we think that there's every reason to start with pilots in these vehicles to get going quickly and operate as safely as possible in the near term with them. And then there's all the support services. So there's both engineering, there's the maintenance, repair, and overhaul. If we're able to develop the network in the way that we think the demand will push it, from our simulations, there'll be demand for many, many, many aircraft in this type of network over each of the cities in which we operate. And so there's all the corresponding jobs that come with that in terms of the maintenance types of jobs, in terms of just operations. So there'll be some number of operators at each of the skyports in which we operate from that will be very interesting jobs, and these are all very localized jobs too. So it's not like you have to go far from home on a daily basis to work in this type of a network. And so that's our vision for it.
Well, how are you, as part of that, how are you planning to work with the City of Dallas on building the infrastructure necessary to service this service that you're offering to provide, and with other cities as well? Because obviously cities plan long term, and they need to have some kind of ability to plan for this. And if we're going to really integrate this, how is Uber planning to work with cities on that?
Thank you for the question. So we are trying to work pretty tightly coupled with the cities, all the different cities in the Dallas Metroplex that we're talking to, including not just Dallas, but Fort Worth and Frisco and others. And so we are. What we're trying to do is make sure that we give them early insight into what we're thinking. But we're also partnering with private companies, real estate companies, on the skyport. One of the nice things about this type of a network, vertical takeoff and landing aircraft, is that the infrastructure requirements are quite small compared to what you think if you wanted to put in a new road network, for example. It's a really interesting characteristic of these types of vehicles and networks that they scale by the nodes, essentially. And so you actually put in one more skyport, and you get connectivity to all the other skyports, which scales much better than roads by the mile from a cost perspective. So we're working with private real estate developers to basically develop in a partnership model these types of skyport infrastructure that we need, and keeping the city apprised of what we're doing.
Well, thank you, Mr. Allison. My time is almost expired. Obviously, I have some safety concerns as well that I might be reaching out to you about, and if you could submit some written testimony on that as well, that'd be great. I yield back, Mr. Chairman.
Thank you, Mr. Allred. Now turn to Representative Stauber of Minnesota, and after that, Mr. Payne will be the next Democrat. Mr. Stauber for 5 minutes.
Thank you, Mr. Chair and Ranking Member Graves. I graduated in 1984, and one of my bucket lists was to become a private pilot. I can share with you that I'm in 43 hours of the Cirrus SR-20 and SR-22. This congressional run and my current occupation here serving the public has stalled my training, but I can say the last flight my instructor says you're ready for solo. I'm not there yet, so I've been interrupted. I will also share with you, you talk about the pilot shortage and what have you. My senior one of my boys is a senior in high school, and on March 22nd, we will be going to the Aviation Career Expo at Lake Superior College in Duluth, Minnesota, a very well-respected college that teaches pilots to fly and gets them interested in the aviation culture. You know, something that I really want to detail is the NOTAM system, and this is for Captain DePete primarily. We know that in 2017 in San Francisco, the Air Canada bus nearly landed on a crowded taxiway, and they mistook it for a cleared runway. Information about that runway closure could have been prevented. The information was located on page 8 of the 27-page list of the San Francisco Airport NOTAMs. The NOTAMs also are frequently state there's birds in the area, what have you. We don't know what type of birds, if they're on the runway, in the air, or nearby. So Captain DePete, can you please discuss some of the issues with the current state of the NOTAM systems and the concerns you have?
Yes, sir, and thank you for that question. I share those same concerns for many, many years. During my 40 years of flying, I haven't seen very many improvements. In fact, I was really delighted when I heard the chairman of the NTSB mention the problem. I've seen and heard of various efforts underway to streamline it. Believe it or not, in my airline, the technology is such that I can use an iPad that'll actually decipher that, but it's still buried. There's still too many. You think about the expectation. You're showing up for a flight maybe an hour before, and especially if you're flying international, and you're literally presented with a paper stack about that tall, about that thick, and you have to weed through that to see what is relevant and what isn't. And it's almost, I mean, you'd really have to, you'd have to show up. We do whatever it takes to make it safe. But I share your concern with that, and we're actively working to try to fix that. We've got folks that are working in the air. We have the largest non-governmental safety organization in the world, and we're working with the FAA to somehow fix that. But again, you know, this really comes down to the funding issue again. You know, the FAA's taxing, there's so much coming at them from so many different angles, you know, between UAS and commercial space, and we're all a part of that effort. But a steady, reliable source of funding would be a step in the right direction. So thank you for the question.
Thank you, Captain, for that answer. And as Ranking Member Graves talks about, aviation is an extremely safe way to travel, and we're going to make it safer. And I appreciate you talking about the funding, because that's what we're meeting for today. So, Captain DePete, I will say this, that I am introducing a bill to form a task force to address these concerns with the NOTAMs, and I hope you'll take part in it. And I think that's one of a number of additional safety items we can bring to the pilots and the culture in aviation, and I hope you'll support that.
Absolutely. Thank you very much.
Mr. Chairman, I yield back.
Thank you. Before recognizing Mr. Payne for 5 minutes, just a heads up for Mr. Perry, who will be the next Republican. Mr. Payne is recognized for 5 minutes.
Thank you, Mr. Chairman. Ms. Cooper, Newark Liberty International Airport is in my congressional district, and on January 22nd, 2019, air traffic was suspended at Newark due to a drone sighting. Over 40 flights were held at the gate, while dozens of other planes were left circling, including a United Airlines flight from Jamaica just minutes away from running out of fuel. In addition to being on this subcommittee, I am also a member of the Homeland Security Subcommittee, and I am very concerned about the use of drones for the wrong reasons. Reasons such as a terrorist attack or to cause air traffic disruptions like we experienced in Newark. Do you have any insight or suggestions about how countermeasures that would be useful for the FAA to look into so that Newark and other airports across America can defend against terrorist attacks or other nefarious drone attacks?
Thank you for your question. There are a couple of aspects to your question. So there's the careless and the clueless operators, and then the criminal and terrorist operators, and we deal with them separately. In terms of the careless and clueless operators, educational initiatives similar to the Before You Fly campaign will help get us there. Remote identification, once that's in place and implemented in a lot of the drones, already currently, but in all of them once the mandate is in place, that's going to go a long way to help with enforcement and additional education and compliance activities. Our company provides a Lattice software solution that's integrated into about 80% of the drones flying commercially and as hobbyist drones in the United States. And that geofencing solution actually marks where the airports are, as well as critical infrastructure, prisons, places that are too sensitive for people to fly generally without special permission. And so that technology is already available today, and industry has been helping things move forward to help prevent these types of incidents from occurring. In terms of the criminal activities, we're going to need countermeasures in place, and Congress has acted to extend those authorities to a couple of agencies in the Reauthorization Act.
Okay. And you mentioned the importance of remote identification in your testimony. Can you discuss the role that remote identification could play in stopping the use of drones for the wrong reasons, such as terrorist attacks causing air traffic disruptions or illegal actions like smuggling narcotics?
So remote identification is already implemented in a lot of the drones available today. However, there's not a legal mandate for operators to comply. Remote ID will help solve the needle in the haystack problem. So currently you can't tell who's a friend versus a foe when you see a drone flying. So this will help with enforcing local laws as well as federal laws that are already in place that are technology neutral.
Well, thank you. Mr. Chairman, I'll yield back.
Thank you. Before recognizing Mr. Perry, just a heads up for Representative Davids from Kansas will be the next Democrat. Mr. Perry for 5 minutes.
Thank you, Mr. Chairman, and thank the panel for taking the time to travel and be here. Questions specifically go to Ms. Cooper. The FAA recently published their ANPRM regarding, I think it's overflight of people and safety and security. I'm just interested in your views on the proposed rulemaking. In particular, the FAA is asking questions on how unmanned traffic management system should be implemented while NASA is completing its R&D work, and the FAA is in the midst of a congressionally mandated pilot, UTM pilot program, to answer some of these questions. I'm just wondering if, look, I'm glad the FAA is moving forward. We all are, and we're very interested in seeing them complete a product. But I'm wondering if if you feel this might be premature, or if they're on track.
Thank you very much for your question, Congressman. During the federal shutdown, as you noted, the FAA released 2 draft rules for operations over people and safe and secure operations. We're still working through what was provided in those draft rules. In terms of operations over people, we believe that the kinetic energy limitations that were identified are a little bit too conservative and restrictive, and are perhaps not in line with the recent research that Assure completed on kinetic energy. So we would like to see that framework become a little bit more flexible, and to also see alternative means of compliance with the rule once it's implemented. In terms of safe and secure operations, there are various provisions in there. UTM is one of them. I think it's too early to be asking for a public comment on UTM, since UTM has already been implemented in stages, and there are various research programs looking at UTM currently that will help inform the draft rule. So I think it's too early to ask for public comment at this stage, while industry and NASA and FAA are working on UTM implementation. Once we get to an actual proposed rule, then that would be the time for public comment. Thank you.
All right, thank you for that. And further, I think it's been since 2016 since the first regulations were issued. I think most of this is contingent. I think you already had a discussion with Mr. Payne about implementing remote ID. Do you know what from your from your vantage point, what is your feeling on what's the holdup on a remote ID requirement and that rule? What do you think the holdup is?
Again, I can't speak for the FAA or for any other agencies. From my perspective, there seems to have been a disconnect in the discussions between the various agencies that need to work to get this rule implemented. And it's been difficult for industry to find out, who actually holds the pen currently and, who is the decision maker that will help, put the rule out finally.
So, and I'm not going to try and put words in your mouth, and I'm not asking you to speak on behalf of agencies, but I am interested in your opinion. So it sounds like it's not a technology issue.
Absolutely not.
Not a technology issue,
The
right?
technology is already available commercially today.
Right, right. And you even spoke about the software that your company offers. Probably there's a myriad of options there, but it's an issue of coordination and who wants to take the lead. Is that?
That appears to be, that is my best guess.
Is there any, I mean, who else would take the lead if not the FAA? Would it be Homeland? Who else would take the lead?
The security agencies are the reason why the rule needed to be drafted in the first place. And in the Reauthorization Act, Congress did direct DHS to identify a point person for UAS industry to work with on these types of issues.
And I was there on Homeland when we did that, to work with the agency when they developed the issues. But it seems to me it's in the purview of the FAA. But if I'm wrong, and if the industry thinks that that's not correct, that's what I'm looking for, is your perception. Is the FAA, in industry's perception, from your vantage point, the agency to take the lead on remote identification for UTM and UAS operations?
Absolutely. The FAA held their rulemaking committee, and they would be the correct agency to move forward. Thank you.
Thank you, and I yield.
Thank you. I recognize Representative Davids for 5 minutes.
Thank you, Mr. Chairman. So I'm actually going to start off with Mr. McBride and Dr. Dorado. I am from a district in Kansas that we certainly have a lot of high-skilled, high-tech aerospace folks there, and we're building strong pipelines of students. And we have, in fact, at the Shawnee Mission School District, I got a chance this year to see some of the students in action, but we've got a career and technical education pathways cluster at that school. And it allows students to start studying aerospace engineering before they head off to college. And I heard earlier the Concorde being designed kind of pre-CAD, and there were engineers designing this stuff before we had the technology that we have now. And so I wonder if both of you or either of you can talk to me about what should I talk to the students about? What is their future going to look like in 2050, and what are the things that we can talk to our students about to get them excited and engaged in this?
One of the things to talk to the students about in aerospace and to get them engaged, that there is a bright future, and that aerospace, although there's a lot of mature technology in there, mature aircraft flying, there's a lot of opportunities for innovation yet. The supersonic aircraft that Mr. Dorado's company is building and developing, and the X-59 are examples of two different types of supersonic aircraft. The X-59 purpose is to validate NASA's understanding of sonic boom wave mitigation and the physics of the sonic boom as it travels through the air. And it's really an experiment testing people on the ground and their acceptance and ability to tolerate sonic booms in overland flight. But for students, the message is in aerospace is there is yet a lot of technology to be developed in supersonic, subsonic, and unmanned aircraft as well.
And I agree with that, and I would say there's basically two things. So, talking to students, you can appeal to the benefits to humanity that come from enabling this travel. And I think it's remarkable that you can enable people to experience different cultures. You can enable policymakers from different countries to get in the same room. You can start new businesses that employ people in other countries and domestically. And I think so I think there's a huge benefit to improving human lives. And I think the other angle is that this is going to be a growing industry in our view. As I testified, as speed increases, people are going to fly more often. That means more planes, more operations, more everything. And so we really see aviation becoming a much bigger part of people's lives in the next 20, 30 years than it is today, even. So I think this is a very good career path to go down.
That's great. And so I'm really excited to hear that. And then Mr. Allison, as a company that I think probably plans on being a place for the young people coming out of my district and a lot of our districts, you mentioned the number of jobs and how many, the variety of jobs. One of the reasons our aviation space is so safe is because we have folks like air traffic controllers, the pilots, the flight attendants who all are, one, treated very well because they have unions that help advocate for their safety and public safety. I'm curious how you envision, and what should I tell the students about the prospects for their jobs in the future when we have folks like Elevate out there providing these kind of jobs.
Thank you for the question. I think I echo the comments that have been made already, that there is just incredible potential here, and we're just scratching the surface of it. That there's just so much innovation that is yet to be done to create whole new sectors of the economy, essentially, that aviation will play an incredibly important role in. And I think that there's many different business models that have yet to be explored as we get in the next few years that we'll start to explore, that others will start to explore when these services become closer to launching in a commercial way. But I think that like all aviation jobs, the demand will be huge, and so there's going to be incredible potential for the types of work that different young people will want to do in the different sectors that I was mentioning before.
Thank you. I yield back.
Thank you. I recognize Representative Balderson for 5 minutes.
Thank you, Mr. Chairman. My question is going to Mr. DePete, and everybody has kind of gone around this as I've been sitting here listening regarding the importance of jobs and the lack of availability that's out there and people that are coming up. But what would you say? I mean, we have an expected need of 790,000 pilots by 2037. What is there for Congress to do to address this issue? And I myself got in a flight simulator, and I want to be a pilot tomorrow because my experience with it was just phenomenal. So what can we do as Congress to encourage some of the things to get people motivated and interested in this? Well, I think like I had mentioned earlier, thank you for the question, by the way, maintaining a viable career is really a key component in attracting people into this profession. We've worked very hard and diligently over the years to build the type of career that people would want to actually come to. They could actually raise their families, have viable jobs, be productive members of the community. And right now we feel like we have a really good, safe system right now to attract people in. But I think you have to really look at the fact that right now, as it exists, an OMB study, that there are twice as many airline transport rating pilots out there than available jobs today. So the question would become, why aren't they coming forward, right? And so there have been improvements over the years, the last several years. So I think if Congress focused on that to understand the viability and looked at the threats to our industry as well. I mean, if you ask me what I thought one of the biggest threats to the industry is, and to this profession, it's unfair foreign competition, you know, through the likes of, you know, subsidized airlines and also atypical employment models, because all that wonderful things that you've worked so hard on to put in FAA reauthorization will be meaningless. So that is a really, you know, making a fertile ground to grow this industry is extremely important for Americans and American workers. So, thank you.
Thank you for answering that. And part of my follow-up was to what you just went into regarding that. What technologies can we do to get our students interested in this career, aviation, or having those cargo pilots move forward to the next level?
Absolutely. You know, and that's why we're so heavily invested in our Future of the Profession initiatives. STEM programs, hugely, if you could support those. In fact, recently, several weeks ago, I met with Secretary Chow, and you know, she's a very strong proponent of those programs. And building the pathways and through a good educational system accessible to all is a clear win. So.
Okay, thank you very much. Mr. Chairman, I yield back my remaining time.
Thank you, Representative Balderson. Representative Craig of Minnesota is recognized for 5 minutes.
Thank you so much, Mr. Chairman. Captain DePete, I just wanted to say hello to you. My district is home to over 1,000 Delta pilots. I'm sure a few other airlines live there as well. And they're proud to call Minnesota home.
Great.
In your testimony, you stated that in a future with autonomous flight, there will be no pilot in command of various forms of aircraft. Can you talk a little bit this morning about how you think the role of pilots will shift in the coming decades, and what skills do you see in the future that will be necessary?
Thank you for the question. Yeah, you know, I've been flying for 40 years, and I've seen the introduction of technologies that are assistive and work, and other ones that, quite honestly, are just burdensome, and we have to work around. The level of artificial intelligence capability to equate to a human in a cockpit is, in my view, that's a pretty far reach. I said earlier, also in my testimony, that the most important safety feature on any aircraft is minimum of two, just for redundancy purposes, right? Well-trained, well-experienced, well-rested flight crew members. I can give you an example. You know, if this was an envelope, you know, our acceptable level of risk that we fly in, we like to be at the top of the envelope, the middle envelope. We don't like when we get to the bottom. But you know what? Sometimes we find ourselves think about, you know, out of the envelope and think about Sully Sullenberger, what happened there. We're trained to deal with those kinds of situations. So I think as we envision this brave new world of autonomous flight, I think it's going to require also a level, and you mentioned Delta, so let me, if I could, just for a minute. There was a Flight 86 in December of 2017. An engine failure had them land in Cold Bay, Alaska, with life-threatening freezing conditions. They had almost 300 people on board an airplane. The town that they landed in on this World War II era runway had 6 parkers. The one restaurant in the community was closed for the season. There were a few townspeople. You couldn't even get all the people off the airplane, so they had to separate the people from one building to another building and then some on the airplane. The 3 flight crew members went out and bought frozen food at a supermarket and started to cook for the people on the plane and the people in those other buildings. What I'm saying here is autonomous. I'd say that emergency began the minute they hit the ground. It continued. And, you know, think about the level of infrastructure that would be necessary to sustain that model, to really to make that model truly what we are. You know, we talk about we're as safe as 10 to the -9, right? You know, a billionth. And so we have the safest system, and it's been made through leadership, collaboration. And what I'd like to see in terms of, you know, particularly in drones and the new technologies, is a little, it needs to be a multi-stakeholder approach because we all share this airspace, right? And so if we could continue, we have the secret sauce, we know how to do this right, we're a perfect example of how to make it work. So, thank you for that. Yeah, appreciate that.
I want to follow up with a question that isn't related to today, but certainly related to the sentiment, and that's safety. We're seeing this morning that the 737 MAX 8 fleet is being grounded in other countries. Do your pilots feel safe right now flying that airplane?
Here in the U.S., FAA has been extremely proactive. And, you know, I'm always reticent to want to comment on any, you know, investigation that's currently underway, because we really don't have the facts of the recent Ethiopian accident right now. And, you know, as tough as it is, and it's terrible, I mean, my heart goes out to all the families of the passengers and the crew, but we have to really avoid speculation at this point. But in general, answering your question, you know, ALPA was very proactive, and so was the FAA, and so was Boeing for that matter, to provide our crews here, which are highly trained crew members with minimum standards that don't necessarily truly exist in rest parts of the world, that gave us a methodology by which to deal with that safety of that airplane. Now, things are changing really rapidly. I wouldn't be surprised if when we're done with this hearing that there could be more news. So,
I appreciate your response to that. Thank you.
Thank
Mr.
you.
Chairman, I yield back the remainder of my time.
Thank you. Recognize Representative Smucker of Pennsylvania for 5 minutes.
Thank you, Mr. Chairman. Ranking Member Graves, thank you for holding this hearing. It is fascinating to envision how air travel will change and change our lives over the next few decades, so it's great to be part of this. I do specifically want to talk with Mr. Allison about urban air travel and the potential there. You've described it even as an entire new ecosystem, and I'd be interested in hearing how you envision that will roll out and how it will develop. You already mentioned in answer to a previous question that you expected the average trip would be about 25 miles. Do you envision that would start as travel from city to city or within a city? And then you also mentioned, I think, what you called a skyport. And I'm interested in how much space that would take to develop that. And do you, at this point, I guess it would be a point-to-point transportation, almost like a tram or a subway. But do you envision at some point that would be flying from building to building or things of that sort?
Thank you for the question. Yes, so when I talk about an ecosystem, I mean that there are a number of technologies that have to all come together in different ways through different forms of partnership with other players in the industry to make it happen. And so there's vehicles, and we have vehicle partners that I mentioned that we're working with. There's infrastructure. We have infrastructure partners, big real estate firms around the world that we're working with. And then there's the network and the operations, and we're building a lot of that ourselves because we think that's where our core competency lies. And so, but all these pieces have to come together in the right time frame and in the right way to make this possible. We envision this being a true multimodal journey. So that means that through our back-end technologies, when you press a button to get a ride or to get a flight, that will provide whatever the best form of transportation is to get you to the skyport, whether that's a car or an autonomous car or a bike or a scooter, as we're introducing in many different markets right now, to get you to the skyport, transition to the air vehicle, to the remote skyport, and then on the same thing on the other side, and I'm automatically provided with the right form of transportation to get you to your final destination, so you can minimize the number of skyports that you need in a network to serve the area. And so we think that's actually really important to kind of make sure that the investment is correct and to roll out these networks to make sure that each skyport has the maximum effect in terms of increasing connectivity to the rest of the network. We do see this starting as a small network. We've talked publicly about something like 5 skyports in an urban area to start with, like the Dallas Metroplex, which is one of our launch markets. And then the envisioned way the network would work is that any vehicle could fly from any skyport to any other skyport, so they would be within the kind of the range constraints of the vehicles, so that you have true one-to-many connectivity, though, between the skyports, which makes the whole network work much better. And then the size of skyport depends on the scale of operations. We envision them starting out very modest, maybe perhaps a retrofit of a parking garage, a top deck. And we actually see with the broader trends in the transportation industry of the reduction in use of privately owned cars in different markets, that parking garages are becoming underutilized in certain areas. We think this actually provides a very...
I'm going to jump in. I don't have a lot of time, but I agree with you. There's potential here, and my next question was exactly that. We could solve a number of problems. Parking would be one of them. Congestion would be another. That is all dependent on the scale, and frankly, the pricing seeing the way the model could work. Do you see this would initially be sort of maybe a luxury, only a few people could afford it, and gradually prices would reduce? Or where do you think, what do you think it would take to get to the point of using it as mass transportation, maybe a daily transportation by folks?
We see this in 3 stages. We see initial launch in these small networks as on a per seat mile basis, similarly priced to our Uber Black product in many markets. So something like $5 to $6 per seat mile. We think that with no changes to the vehicle, but only with operational efficiency and higher utilization and load factor, we can get down to something like $1.50 per seat mile within a couple years of driving utilization. We think that ultimately, with the introduction of autonomy and the reduction in capex of building these vehicles by applying automotive type manufacturing technologies, we can get to something that's close to the marginal cost of car ownership per seat mile, which is something like 45 cents, I think the AAA said.
And I don't have much time, but I agree with Ranking Member Graves said earlier, you know, we here, our role is not to try to sort of drive various technologies. Our role is to try to envision what the future could look like and be sure that we've gotten out of the way so companies can innovate. So I'd be interested in continuing discussion with you at some point in regards to what you think, what changes need to be made here to ensure that innovation can be driven not only by your company, but by others that are operating in this space. So thank you.
Thank you.
Thank you. The next 3 members I have in order will be Representative Carbajal, Representative Katko, and Representative Titus. I recognize Representative Carbajal for 5 minutes.
Thank you, Mr. Chair, and thank you to all of you for being here today. Mr. Allison, thank you for sharing a little bit about what aviation might be like in the year 2050. There's been a lot of exciting and innovative technological and designs that no doubt will have a major change in our transportation system in the future. Advances to engine and commercial space vehicle designs, such as hybrid electric and all-electric engines or alternative fuel sources, which could make flight operations more sustainable and environmentally friendly. Could you please speak further on what this might look like for your industry?
Thank you for the question. Absolutely. We actually view the transition in technology to the introduction of electric powertrains into vehicles as one of the key enablers to make this whole industry of urban air mobility possible. And so the way this plays out is that with electric propulsion technology, the same types of technology that go into electric cars that enable them to be much simpler and cheaper to operate, allows you to create new topologies of aircraft that can take off and land vertically like a helicopter, but can transition to a wing and fly much more efficiently and quietly. And so you can reduce the energy cost dramatically in these types of vehicles by using electric technology, and that actually enables then this whole market to open up. But the key enabler is electric propulsion applied to aircraft to let them take off and land vertically in a quiet and safe way.
The Jetsons come to mind. Thank you. Captain DePete, thank you for your testimony before our committee as well. Some of the concerns I have heard from my constituents as we continue to develop new technologies are how do we maintain a competitive workforce for the future? What are some opportunities or recommendations you would propose to meet these challenges, 1? And 2, in your testimony you mentioned improving diversity within the aviation workforce. Can you explain further on what this would look like?
Absolutely, thank you. And we are intimately involved in every aspect of diversity across the board, including participation now with the new requirement for the Women in Aviation Working Group that's going to take place on. And we have already placed a person on that to represent us. There's 14 members, I believe, on that. But this all comes under our efforts of what we call a professional development group, and that area that I told you earlier was the future of the profession. So we're really heavily invested in encouraging people to come forward and get involved in studies that would help facilitate a career in aviation. Of course, I was a poli-sci major, I will say that, but I still got in. But having said that, I think that anything that Congress can do to help facilitate and support that kind of an educational process, as well as the career aspects that I mentioned earlier, to make it a viable career and to protect the industry as a whole. Because if we lose the industry through unfair foreign competition, we lose everything. So that would be my.
Thank you very much.
Thank
and
you.
Semper Fi, Dallas.
Thank you. Thank you. I appreciate that.
Mr. Chair, I yield back. I forgot to say that.
I think we're all more than happy to sit here in silence for a minute and 30 seconds. I recognize Representative Katko for 5 minutes.
Thank you, Mr. Chairman, and thank you all for being here. It's truly fascinating. I finished a book recently about the Wright brothers, and when they started out, they were bicycle shop owners, and they just started fiddling with the audacity of air travel. And by the end of their lives, one of them was riding on commercial airlines. So it's really amazing what can happen in a lifetime. And so everything you're talking about sounds kind of out there, but quite frankly, it did to the Wright brothers too. So go at it and have at it, man. But question I have is on the drone technologies. In my district, in my neighboring district, we have one of the premier drone technology research corridors in the country. And, you know, I'm vitally concerned about the amount of vehicles that are going to be in the air in 2050 and the amount of unmanned aerial vehicles that are going to be there, package deliveries, all the things. Lord knows what's going to be there. But I'd like to just kind of hear your opinions as to what you think is additionally needed in order to affect that. Obviously, geofencing and all those types of things we're going to need to keep those unmanned vehicles out of air traffic, commercial airspace is a vital concern. So anything, wide open to you guys. I want to hear what your thoughts are about the drone technology, where you think it's going to be and what we need to be doing with it right now.
Thank you for your question.
We picked you, Ms. Cooper, first. Go ahead.
As the drone member on the panel, I'll kick this one off for us. As I mentioned earlier in my testimony, remote ID is sort of the next thing that we need to work on together. And once that's implemented, you know, we can deal with any concerns that are cropping up, perhaps in your district and others, in terms of privacy, trespass, and other laws that we already have in place that can deal with this new technology and all of its concerns. We just currently don't have a technological means to enforce those laws, and remote ID will help us get there.
Great, great. Anybody else?
I think working with the FAA and our industry partners to help establish the standards for performance and certification of these vehicles is going to be one of the key components to moving forward.
Yeah, obviously, I also have I wear a terrorism hat from Homeland Security, so I'm also vitally concerned about weaponizing these unmanned vehicles, whether they're airplanes or what have you. And also, from a cybersecurity standpoint, the ability to hack into some of these systems and maybe take over an airplane and weaponize that as well. So I think, you know, if you want to comment about that as well, I'd like to hear about that.
Thank you, and I'd like to thank you personally for all the help that you've given us in terms of the security aspects when it dealt in relation to cargo.
Yes,
but
and more to go, though.
Yeah, we have a bit of a way to go, but your interest and support in that has been very appreciative. To answer your question, member of the Drone Advisory Committee subcommittee, and we worked on, looking at what type of infrastructure would be necessary. So right off the bat, I'd have to say sufficient funding, right, for the FAA and consistent funding. And earlier, before you joined us, I had mentioned, we had made so much progress in the FAA Reauthorization Act in terms of the 5-year plan, but yet we had to deal with government shutdown. That was so I'm really supportive of HR 1108. And like to see, so could we keep steady progress going? But I think if we focus on infrastructure and also on I happen to draw the lucky straw and get the funding model to try to figure out how we're going to pay for all this, And I think what we have to be careful about is we have to do this right. If we have an opportunity to do this right the first time, because if something doesn't go well, if we introduce risk too quickly and it's uneven where other operators abide by a certain set of standards and the other ones don't, it lowers the risk, it raises the risk for everyone in the system.
Oh, much can be said that's what happened with respect to the Internet.
Absolutely.
I mean, it was introduced before they understood what cybersecurity was and cyber vulnerabilities.
Absolutely.
It's the same thing, yeah.
Couldn't agree more. And what it will do is it will set back the industry for the folks that are trying to do it the right way.
For sure.
So we do have a unique opportunity here. We just have to figure out how to fund it.
Well, I encourage all of you to continue to look around the corner and think boldly, because that's how progress is made in this country. But to try, when you're doing that, also try and anticipate better than we did with the Internet is a great example of the vulnerabilities that are going to be there. And with the unmanned aerial vehicles, there's tons of vulnerabilities. It's highly complicated. We got to get it right. If we get it right, I think the technology is going to be amazing for us in the next couple of generations. But we've got to be very mindful of the misuse of drones, misuse of unmanned vehicles, and we've got to do it better. We've got to anticipate that up front. So, anything else we want before I yield back? Okay, I yield back, Mr. Chairman.
Thank you.
14 seconds ahead of time. That's a first for me.
Appreciate that very much. Yeah. We can all leave earlier. Thanks, Representative Katko. Representative Titus for 5 minutes.
Thank you, Mr. Chairman. You know, in the 2 hours that we've been sitting here listening to all the exciting new technology and what we need to do and how we can be safer and all the developments that we can be made, our president has tweeted out something pretty interesting. Airplanes are becoming far too complex to fly. Pilots are no longer needed, but rather computer scientists from MIT. I see it all the time in many products, always seeking to go one unnecessary step further when often old and simpler is far better. All of this for great cost, yet very little gain. I don't know about you, but I don't want Albert Einstein to be my pilot. I have a hard time interpreting anything the president says, but I don't know if this is a knock at Boeing or if it's a knock at pilots or if it's a knock at Einstein or just he's just a Luddite and it's a knock at technology general. But it doesn't seem to be the right attitude at this moment and certainly not in this hearing. I want to ask a general question. I believe we still have an acting director of the FAA and an acting deputy director. Do you all find that this is a problem in trying to get advances made in this field? Has it put up obstacles, or is there a reluctance by the agency to move forward because we don't have somebody in place? Anybody?
Well, from NASA's perspective, I think we have a great working relationship with the working level people in the FAA, so progress continues to be made at the engineer to engineer and management levels at the agency. I can't really speak to higher levels of the agency.
How about from the industry standpoint?
Thank you for the question. We are part of the IPP, the Integration Pilot Program, with the San Diego team, and we've been incredibly pleased with the way the FAA has been working with us, and we couldn't have it's just going extremely well, and so kudos to them for really leaning in and engaging with industry in a very meaningful way to really try to do things right, but also try to move very quickly. And so we've been incredibly pleased with how the FAA leadership's been working with their teams to get that done very, very effectively.
That's good to hear.
I agree with Mr. Allison's comments. Under the acting administrator's leadership, the FAA has rolled out several programs, including the IPP very successfully to date, the UPP, which was recently announced, and the proposed rules that we talked about that were dropped during the furlough. So I think they're doing a great job, and we look forward to continuing to work with them.
We usually hear that they're pretty hidebound and very slow to respond, and they come along after the industry, which puts us behind the rest of the world. But perhaps maybe there's been some improvement, so that's good to hear. I have a more specific question that's related to the UTMs that some of you mentioned and how they can tie to the testing centers that exist in several states, including my state of Nevada. I know we're eventually going to develop a system that will be applicable to what I'm going to mention, but in the meantime, I wonder if you could give me some advice on what we might do to allow this to happen. Some of the commercial users, like utility companies who have rights of way on the ground, would also like to have rights of way in the air to be involved with things like remote wires that are in areas of Nevada that you can't get to very easily, or perhaps fixing railroads or pipes. Is there any possibility, working with the testing centers, that we might develop some kind of airways where the drones can go that are tied to other infrastructure projects where they might have right-of-ways?
Well, that's certainly in our plans at NASA to work with the FAA, the established test centers at Edwards Air Force Base, where Armstrong is located. We're in a restricted airspace, so a lot of our initial work happens there without the need for COAs or FAA authorization to fly. I did mention in my testimony the Grand Challenge activity moving forward. Initial Grand Challenge is planned for our facility at Edwards in Southern California, but we are looking at the Nevada test site as a potential alternative location to move some of our mobile facilities to and do some of the Grand Challenge work there as well.
So do you think that the FAA should kind of carve out or create these restricted fly zones or corridors that parallel critical infrastructure?
That is going to be something for the FAA to decide, but certainly that's within the capability of UAS to do monitoring of critical facilities and infrastructure like railroads, power lines, transportation throughways.
How about you, Ms. Cooper?
Thank you for your question. Congress directed the FAA under the Extension Act to set up under Section 2209 a process for critical infrastructure facility owners and operators to seek no-fly zone designation. That's another provision that we're still waiting for the FAA to implement so that we can move forward and help protect critical infrastructure.
Well, maybe since they're doing better, they'll move forward quicker.
Hope so. Thank you.
Thank you. I yield back.
Thank you, Representative Titus. I recognize Representative Stanton for 5 minutes.
Thank you very much, Chair Larson, and thanks for this great panel. It's so important that Congress take the time to do meetings like this, to hear from leaders thinking about the future. We so often deal with the immediate challenges, sometimes crises right before us. So this is a very, very important thought process, and have these thought leaders before us is very much appreciated. I come to this committee as a new member of Congress, but having spent many years as a mayor of a big city, Phoenix, Arizona, where I was, I guess, the chair of the board of Phoenix Sky Harbor Airport, and had a great working relationship with the aviation, the airlines, the industry as a whole, a lot of the great employees that make up the industry. I was also a champion of a major infrastructure investment initiative that we undertook in our city, transportation initiative. And a lot of the investment went to light rail and to improving our bus system. And many people challenged me and said, why would you invest in those old technologies or those old systems when transportation is going to look so different in the next 50 years? Are we going to need light rail in the future when we have driverless vehicles or the ride-sharing companies are taking over transportation? My response was, of course, that a great city has to have as many transportation options as possible. It's not an either-or proposition. And so we need to continue to invest in outstanding transportation options like light rail. I'm looking at this in very much the same mindset. I'm excited about these new technologies and what they might mean for the American economy and American technological leadership in the world, but also at the same time hoping to get out of this committee a proposal for a major Infrastructure Investment Act for the United States of America, and maybe ask your advice about what infrastructure investment should we be looking at differently in light of some of the technologies that you're talking about, or some add-ons to the potential infrastructure investment that we'll be making, recommended through this committee. What does infrastructure look like differently as a result of some of these exciting technologies? And that's open to anybody. Captain, please.
Thank you, Representative Stanton. That's a great question. You know, we envision, you know, an airspace with multiple users, right, all trying to share that. So collaboration is really a key here. And you know, I've always believed that if you have a goal in mind and you crystallize that, you have a pathway now instead of meandering back and forth. So I think an open, transparent, collaborative process with the help of Congress in every way it possibly can to protect the industry, like I said earlier, and facilitate that dialogue. You see what goes on in the commercial aviation safety team that I mentioned earlier. That risk predictive model is a very useful tool, and it goes hand in hand with success, right? Because if something goes wrong, or if you go a little too fast and you try to cut a corner, then it affects the whole thing, and it changes the perceptions to the public. So I think anything along those lines would be, but that's what it's going to look like, including commercial space. Airline Pilots Association, I was at a ComStack meeting last year, and when they said the mic is open, I grabbed it and I said, you know, from what I'm hearing from everyone, it sounds like we could all benefit from, because there was some concerns, right, between commercial aviation and commercial space. It's not like they're a new entrant, like, say, drone use or anything like that. They just have a enhanced capability now due to, but the methodology that we're using right now of, you know, segregating vast pieces of airspace, when we really, there's some low-hanging fruit right now that we can more dynamically manage that airspace, but that requires cooperation, leadership, and so anything along those lines.
That's great advice. Mr. Ellis, how about your technology with Elevate? You talked a little bit, other members asked about infrastructure necessary. I'm fascinated by the opportunities of technology, and as leaders on the infrastructure side, what should we be thinking about?
Yeah, we actually envision, thank you for the question, envision a combination of both private and public infrastructure that will develop over time to support this type of a network. And not just like physical on the ground infrastructure, but the digital infrastructure as well. That in order to do the right kind of collaborative airspace management kind of built up out under that UTM construct, there has to be the digital infrastructure that's run by the FAA to facilitate that. And we think that's incredibly important.
Congressman, I think as flights get faster, so from Phoenix to Tokyo in say 6 hours, people are going to be more sensitive to the amount of time that they spend getting to the airport, right? Which is where Mr. Allison's company comes in. But then also the time that they spend at the airport and going through security and all the hassles and so on. So as wonderful as Sky Harbor is, I don't think everybody wants to spend most of their day there. And so speeding along the process of working through the airport and just getting on the flight and so that you can get on with your trip is
That's great. Sky Harbor is not perfect. We're just better than any other airport in America.
Right.
Yeah.
Thank you for your question, Congressman. As Congress considers what should be included in a broader infrastructure investment package...
Excuse me. His time's up.
Sorry.
Sorry. Thank you, though. We're going to go to a second round of questions. And because I have a few questions to ask, a few more follow-up questions to ask. But we will recognize Representative Stanton as having a fine airport. So back to Captain DePete on commercial space. And the truth of it is we're going to have about the number of commercial launches this year that we had last year, but presumably there's an increased interest in commercial space, both for tourism as well as for traditional uses. Can you describe the effect that might have on commercial airline travel and any concerns, as well as what steps might be taken to accommodate commercial space?
Absolutely, and thank you for the question. And that's the opportunity that I think I saw. And right now, ALPA is really trying to facilitate that dialogue between commercial aviation and commercial space to work out those problems. Because I think, we're going to learn from one another, right? We have this incredibly great aviation ecosystem with all these multiple moving parts and this elegant little dance it does, and with the end result of being very, very safe. And we think there's a lot that we can share in terms of the data collection nets which you have through the Aviation Safety Information Analysis and Sharing Program, a similar type approach that could be quite possibly helpful to them. But at the same time, their advancement in like suborbital flights clearly is going to translate over to the airlines. But the real key is going to be this coexistence in the airspace right now and how since more and more launches will take place, how do we dynamically manage that airspace so we don't create undue burden for other users of the airspace during the launches? There is a plan. I mean, we can do this. It will take increased funding, of course. There's a SDI, the Space Data Integrator tool, that's available that would help air traffic controllers manage some of that space. Unfortunately, there's no automatic link to the ERAM systems that the air traffic controllers use. The information is manually taken from the SDI and brought over to the controller. So there's steps that we could take right now, but we need a short, medium, and long-term vision and a funding process along the way to achieve it. But it's an exciting time. So.
Thanks. Ms. Cooper, I want to now give you a chance to answer Mr. Stanton, Representative Stanton's question.
Thank you, Chairman. In terms of the broader infrastructure investment package that Congress will be considering this year, I believe drone technology could be incentivized as a tool for master planning and redevelopment, similar to the work that I included in my testimony that we conducted with the VA. Drones can help monitor existing infrastructure and help us understand how to best recapitalize that infrastructure, as well as help new projects stay on track and under budget. Thank you.
Mr. Dorado, have you all thought through the impact the Overture will have on airport infrastructure? Do you think there will be necessary changes? Can we use existing infrastructure as is?
Thank you, Mr. Chairman. We are designing Overture as much as possible to work with the existing airport infrastructure. So we'll use narrow body gates. It will be able to take off and land in the same way that airliners can today. The one thing where we are looking at an opportunity for improvement is in steep approach capability at a number of airports. So using GLS as an upgrade from the existing ILS systems at most airports, it's possible to have different glide slopes for different airplanes. And the opportunity with Overture and with supersonic airplanes in general is to come in at a steeper angle and further reduce the community noise on approach. So we'd like to see airports upgrade to have GLS systems that could enable something like that to exist and further reduce noise exposure into communities.
All right. Thank you. I yield back and recognize Representative Graves for 5 minutes.
Thank you. Ms. Cooper, in your testimony, you made mention of concerns regarding a regulatory patchwork for the use of unmanned aircraft related to different cities and states and others. Would you mind submitting, and I'm not going to ask you to do this from memory, but would you mind submitting to the committee in writing some examples of where that's happened or just where some of your concerns are so we can better understand, I guess, how that has thwarted or prevented some opportunity for your industry? That makes sense?
Absolutely. I'll do that for the record. Thank you.
All right. Mr. Allison, I see some head shaking over there. You want to add something? You good? All right. You just recognize that that's a concern as well. Got it. Thanks. Another question, Ms. McBride. You made mention of some of the coordination that you're doing with the FAA related to research and development. I made mention earlier to the sonic booms as one example, but obviously there's a lot of technology crossover. Can you talk about how that relationship works and sort of how you made mention to your, doing this from memory, is it RTTs, and just how you basically commercialize or transfer some of your solutions for private sector opportunity?
Yeah, NASA does fundamental or initial research in air traffic management software methods, working with the experimental FAA sites, and transitions that software to the FAA, like ATT2 and MAC software, which allows a better integration of aircraft coming into airports and better coordination with FAA controllers.
Can you talk specifically about how y'all have worked together to actually improve the NAS and any technologies that y'all have resulted from some of the R&D you've done?
I can take that one for the record and get you some written responses on with specific examples how we've matured the technology in those on-ramps over the last few years.
Okay. I'm curious, Mr. Dorado or Mr. McBride, one of the big concerns with the overland regulations that you cite in your testimony, or I think maybe both of you do, can you talk about the state of research related to that and where we are in regard to being able to actually move forward on a regulatory change there?
Yeah, the FAA currently restricts overland supersonic flight outside of restricted airspace or supersonic corridors. The X-59 is leveraging on research that NASA's been doing since we had the first aircraft sonic boom in 1947, and our understanding of sonic boom shock waves and how they coalesce off the aircraft and transition or transport down to the ground and impact people and things on the ground. So we're taking that understanding and putting that into tools which are helping to inform the design, the outer mold line, the shape, the engine placement of the X-59 aircraft, which again isn't a test vehicle as a prototype for a future transport aircraft, but as a experimental aircraft designed to test people and things on the ground. We already know how to make aircrafts, high-performance aircrafts, and aircraft go fast and make sonic booms. The goal with the X-59 is to make a sonic boom, and the sonic boom doesn't go away, but to make a sonic boom soft enough that it's not annoying to people or things on the ground. And so once we clear the envelope and assure that the aircraft is safe to fly, then we'll fly over communities and monitor people's responses. We've been doing some initial work in coastal areas like Galveston and in Florida, where we can put partial sonic booms onto people, but the heavy sonic boom goes out over the water, you know, to measure their acceptance and of the sonic boom and how it impacts them and their families.
Is that also going to help stop my car from vibrating and shaking when someone next to me has a radio on that's too loud?
Probably not help that.
Mr. Dorado, is there anything you'd like to add there?
Yeah, of course. So we are designing our overture primarily for overwater operations, not over land, but we are working very closely with NASA and with FAA and the international community on international rules for overland supersonic flight, and we expect those rules to come into place in the mid-2020s, right? When we've delivered overture and we'll be designing our next plane. So we expect future planes to have that technology. We do think it's important that the standard be written in a way that is accessible to airliner specifically and Mach 2 plus airliner, because that's what you need to fit into the airliner schedules. So it's important that the standard is not too strict that we can't meet it.
Great, thank you.
Thank you, and I recognize Mr. Representative Lynch of Massachusetts for 5 minutes.
Thank you, Mr. Chairman, and Ranking Member Graves for your holding this hearing. I want to thank this distinguished panel as well for your insights. Captain DePete, good to see you, sir. So I'm a former union president myself with the Iron Workers. I know you represent the Airline Pilots Associations, and for my men and women, I was always nervous about their safety. And so I've got some nervous constituents this morning. I actually represent a section of the city of Boston where the departing flights from Logan for a large commercial airline, basically we live underneath that path. And so we've had the Lion Air crash and also the Ethiopia crash, both on takeoff. So not just the people who are flying in the planes, but the people who live under those flight paths are very nervous. And I know this was not what you signed up for this morning, but because my constituents are nervous, I'm nervous, and it would be a dereliction of duty not to ask you about this if you have any insight on in terms of how your pilots might feel about this and what their perspectives are. I do want to note that as of this morning, when I came in, there were 25 airlines that had stopped flying the 737 MAX. And at least 2 countries, I believe Australia and the UK, have basically refused overflights of this aircraft. So maybe you could, I don't want to spend a whole lot of time on this, but I have to ask you, what are your views?
No, it's quite all right, and I really did sign up for this, so I wouldn't mind messing it at all, right? So, we have the integrity of a process that we've had for a very, very long time, right? So right now, ever since the first accident involving the 737 MAX, very engaged with Boeing, very engaged with the FAA, and they created some airworthiness directives that helped some of our pilots, who are very experienced. We don't have any 200 pilots, hour pilots sitting in the seats anymore. Right. No on-the-job training anymore. So we're very proud of that process. And with that process, though, the difficulty with this is that we are closely monitoring the situation. It's like you said, it's changing by the second. Yeah. But the process that we have, that integrity of that process right now, where during an ongoing investigation, it's speculation, because we don't really have all the facts from the most recent accident from Ethiopia Airlines. So once we get all that, but I think the certification standards that were set up with in the discussion with the FAA and Boeing, and the information that was passed to our pilots, feel like we can adequately fly that airplane very safely. But if we hear differently, I understand there's some new changes in software and programs that are going to begin to implement. And quite honestly, we knew about that as early as November. So I think I think we have to, rely on the data and rely on the process that has gotten us to the point where this is the safest. There's been a lot of sensationalism, and rightfully so. I mean, there's a tremendous loss of life here.
Right.
And
absolutely.
we don't want to have that happen again. But the process we need to follow, as difficult as it is, will help us prevent that in the future.
Right. Well, I just hope that your pilots are keenly involved.
They are,
obviously.
Yes, sir.
I do have great confidence in Boeing. I think they're a wonderful company, and they have been a real success story. I want to make sure that all of their sort of review is being done as it should be.
Right.
Make sure we're working this through. I'm just concerned. If there were ever, so we've had 2 strikes here.
Right.
Strike 1 in Lion Air and strike 2 in Ethiopia. If we lost another passenger aircraft,
right,
large commercial airliner, you know what the repercussions of that would be. It would be a complete loss of trust in that aircraft, and it'll go much further than that. So I just want to make sure we get it right for the safety of the flying public and all of our pilots, right?
Absolutely, and we share that concern, and it isn't lost on me that we're talking about a lot of technology developments here.
Yeah.
And how important it is to have a well-trained crew on board the airplane.
Right.
So thank you, though, for
Thank
the
you,
question.
sir.
It is.
Mr. Dorado, you did talk about sort of shifting flights over the water with your earlier remarks. That's one of the things I'm trying to get done in Boston. We designed our airport and laid out our runways back in the 1920s, and we had very weak aircraft, very limited thrust, and we were just trying to maximize the wind direction. And now we've got very powerful aircraft that could easily take off over the water, but we've left our runways where they are. Is there anything that that you see might help us move in that direction of, when possible, like it is in Boston, to maximize the use of over the water flights?
Certainly with Overture, we'll have a lot of excess thrust available on takeoff and landing, and so we are planning to use that to minimize the exposure to communities and to design airport-specific procedures into the flight computer so that the pilot can fly very easily a procedure that reduces the exposure to the community.
Thank you for your indulgence, Mr. Chairman. I yield back.
Thank you, Representative Lynch. Appreciate that. Any further questions from members of the subcommittee? Seeing none, I want to thank the witnesses today for your testimony. Your contribution to today's discussion has been informative and it has been helpful. I think we moved at least 10 years into the next 30 years. As a result, I think we've established a good record for the subcommittee about what the future of aviation and aerospace is for us to build upon in the future as well. I want to, for the record, remind members will be going to the FAA Technical Center at the end of the month to look at some of this technology that has even been mentioned here today. And this hearing has given us much to think about. Ask unanimous consent the record of today's hearing remain open until such time as our witnesses have provided answers to any questions that may have been submitted to them in writing. And unanimous consent the record remain open for 15 days for any additional comments and information submitted by members or witnesses to be included in the record of today's hearing. Without objection, so ordered. If no other members have anything to add, the subcommittee stands adjourned.